Swayam Prabha. Digital India. Educated India.
Hello everyone. So, in this module we are discussing the protection from mechanical threats. As I have already explained in the last module that mechanical threats are of different types, like ballistic protection, where the projectile, any types of projectile like any bullet or any fragment can strike, the impact, how textiles protect us from those impacts, that we have discussed. And next type of threat is that threat from cut. So, in this module we will discuss the textiles which are used for our safety from cut threats, and next module we will discuss another type of safety measure which is stab resistance, and in continue with this mechanical threat, then slash type of threats we will also discuss subsequently. So, at present we are discussing the protection from the threat of cut. First, let us understand what is cut resistant textiles. You can see here in many workplaces that people handle sharp edges, knives, sheet metals, glass, tools. So, in the industry they or any workplaces, so this type of materials people used to handle, and there that threat from cut are very common, and that is why we need the cut resistant textile which are flexible and unlike sprains or strains, like something hit us. So, we will get strain, our like body muscle will get strained or we will get sprains, but cut is entirely different. Cut is that the cut or laceration, they come from direct contact and often hit the hands or any part and causes injuries. So, direct contact with any sharp object. So, cut protective textiles, this cut protective textiles that actually they interrupt the contact. Suppose this is our body part where this, so like our hand, if we use this is the cut protective gloves we are using. This actually gloves comes in between our skin body part and the sharp object. So, it interrupt the contact, and in case of there is a chance of any injury, this it turns the likely injury to a shape grip. So, here there may be a chance of injury. So, that when we are placing the cut protective textile material in between the body and the sharp object, so that we get the safety. So, this type of fabrics are specially designed textiles that protects the wearer from cut, abrasion, punctures. So, we need specialized textile material which will actually protect us from any type of threats from cut, abrasion and puncture. So, here we need a special ability for a textile structure. So, here the ability is that to increase the force or energy required for the sharp edge to sever the load bearing yarn during normal or tangential contacts. So, there are typically two types of contacts, one is normal contact, another is tangential contact. So, the textile which we use here, this is the textile which we use. So, during the normal contact, say this is our textile material, cut protective textile, and here is our body part. Okay. This is body part, and this is the cut protective textile. And any sharp object knife it comes. Okay. Here we have to develop certain yarns or fabrics which will be difficult to cut. So, that is the, and it will increase the energy required to by the sharp edge to cut. Okay. So, that is why here this will simply use to increase the energy required to sever the load bearing yarns. So, that type of yarns we are using, and here there may be normal contact or there may be a, suppose this is a blade which is rotating and here is a this is the surface, okay, surface, and the contact here will be tangential contact. So, this is rotating and there is a tangential contact. So, for both these contacts our yarns or fabrics should be able to withstand. The performance of cut resistant fabric depends on the properties of fibers. So, mainly its modulus, hardness, friction. So, these properties are very important. And then yarn architecture. So, structure of yarn, what type of yarns are used. Normally in cut protective textiles we use the multi-layered composite yarns. So, that we will discuss in detail, and special fabric structures are also required, and the conditions of contact, like whether it is a normal contact or tangential contact or speed of contact, whether any knife or any sharp object is in contact at a slow speed or at high speed, that is also important. At what force it is actually acting on the material. So, everything will actually control the cut resistant property. So, depending on our thread we have to select our fiber, yarn structure, fabric structure. So, if we know the type of threads, type of sharp objects we are handling, so we can design our clothing. So, cut protective textiles we can design. So, let us try to see the overall rates, what are the different at different countries, how the cut threads are actually, what are the statistics, let us try to see. Here you can see for different countries the knife related threads are there, it is a data is of 2019's data. In Brazil having 9,885, South Korea, South Africa is there, followed by South Africa, then India is 8,931, followed by Russia, Philippines, Nigeria, Mexico, China, Pakistan. So, these are the different types of deaths related to knife. So, this deaths are basically mixture of that it is a industrial condition while the people are handling the sharp objects or maybe the riot. So, different types of deaths related to this knife. So, here our the cut protective textiles will be definitely useful, and apart these are the data related to death, but there are injuries are there, large number of injuries take place worldwide. Now, this is the data in 2023. So, Malaysian research related to occupational injury, the reference is given, the source reference. So, this is due to the only the occupational, while actually while the working in the industry or maybe at different even at home. If we see the cut related injuries are 23%, okay, and cut, burn, fall and sprain related 4%, burn and cut related 5%. If you add together, you will see worldwide most of the injuries are related to cut. So, here the cut related textile, cut protective textiles is definitely going to grow, and it will to protect ourselves. So, in United States the data in 2017 data which says that different types of occupational injuries are there. So, here if we see maximum occupational injuries are sprains, strains and tears. So, this is the 35% around, soreness and pain 16%. Now, you can see cut related injuries are 10%, fracture 9.5%. So, all this if you see here, so cut related is a major chunk of the any injuries are in the particularly in US it is there, for other countries we have the data. So, you can see every 10,000 workers 8.1 incidents are taking place. So, number is not that small. So, we need protection from cut related injuries. Now, first let us try to see what are the different industries where this type of cut related threats are there, and where we should make it mandatory to wear cut protective textiles. This is one industry where we actually handle sharp metal edges. So, it will be very difficult. So, sheet metal handling industries. So, there are many industries which handles different types of sheet metals. So, like metal forging, stamping, all these industries the workers handle 24 hours this type of metal. So, where always there is a chance of the cut. So, here this person is working without any protection, but it is advisable, it is now it is mandatory to use the cut protective textiles. In many countries they have actually make it mandatory. So, the metal protective processing factories where workers need to handle the sharp parts, okay, and they always there is a threat of getting cut injury. Next is you can see the glass processing. So, glass manufacturing factories where workers need to handle glass sheets. So, glass edges are very sharp. So, this glass sheets they need to handle. So, here this person is actually wearing the gloves, cut protective gloves. Even you have to wear the apron, cut protective aprons. So, where there is a chance of cut. So, this glass manufacturing factories we have like slaughterhouse. So, there the workers have to handle the sharp edges. So, we need cut protective textiles there. Then forestry industry, continuously they are handling the sharp objects, saws are at high speed. So, there we need cut protective textiles. Next is very important here, recycling and waste handling industry. Here in those type of industries where the unknown waste people handle. So, along with the soft materials there may be some sharp object, okay, sharp edges are there where the chances of cut are always there. So, here we can see the workers they are wearing the cut protective dresses and also the gloves where the chances of this cut are always there. Electronics industry. In electronic industry the people always handle the sharp objects. So, electronic assembling and handling though. So, there we need the cut protective textiles. Food processing industries, there also always they work with sharp knives. So, apart these are the some of the examples. Apart from this there are many other industries where the workers have to handle the sharp objects. Also in textile industries you can see, so construction industries, in construction industries that the workers need to handle the sharp objects, metal objects. So, there we need the concept that cart protective, even in automobile industries, automobile parts assembling, there also the cart protective textiles are important. Pressurized glass bottling. So, there always in glass bottling the cart and puncher threads are there. Pulp and paper industries. So, any industries, any places where we have to handle the sharp object, even at our home while cutting the vegetables or any other matter, while we use this sharp object, and we must actually use the cart protective gloves, because in at home the chance that the data is there that a large number of cart related injuries are reported. Like in textile industries also you can see that sharp object is there, like sharp cutter is trying to cut the multi-layer textiles. Here the chances of cut are always there. So, these are the some of the industries. So, and apart from that, anywhere where the chances of cut are there, in those industries we should use the cut protective material, cut protective textiles. The main advantage of cut protective textiles, again these are lightweight, flexible, and it does not restrict our body movement. So, ergonomically the cut protective textiles we can design. Now, cut is a part of the sharp force threads. So, sharp force threads we can classify. They are classified into 3 categories. One is cut related thread. So, they are basically source is knife, blade, glass. So, these are the typical sources, and this cut is basically quasi static force of knife. So, this is basically at slow motion that at quasi static force is there, and where in the cutting, slicing in a control manner, that is superficial cutting will be there. Here you can see when we are cutting, that does not go in depth. Okay. The injury will be the surface, superficial injury, and these are not that very fast. It is a quasi static, and typically these are from knife or blade or glasses. Second type of thread is thread from slash. So, slash thread we will discuss subsequently in this module. So, this slash type of thread comes from sword, machete, large knives. So, here in cut it was quasi static force, but here forced slice of knife. So, here there is a force involved in the knife, that is slash, which is rapid and sudden movement of knife, and it goes in depth of the muscle. Like in cut it was a superficial and it is a slow motion, quasi static, but here it is a rapid. So, rapid and sudden movement of the knife. Okay. Typically, it is with the large knives or sword, or cut may be small knife, blade or any sharp object. And third type of sharp forced thread is stab related threads. Okay. The stab related threads are basically sources, daggers, knives, needles, which actually penetrates vertically. From this picture we can, it is very clear, the stab is actually it goes vertically, it penetrates into our body. So, vertical impact of sharp tip. Ballistic is different, that is a projectile. Here the impact is actually sharp tip is actually by vertically it is forced. So, here vertical thrust or jab of sharp knife is there and which penetrates internally. So, internal organ gets damaged. So, we see that these are very important aspects. We will deal all these threads separately and they are classified into the sharp forced thread objects, but their mechanisms are entirely different. So, cut threads are cut mechanisms are different from slash and stab is different from cut and slash. So, as their mechanisms of are different, so we have to first understand the mechanisms, then design our clothing accordingly. A cloth may be good for cut thread, but it may fails at the slash type of threads or stab type of threads. This we will try to understand in detail, and first we will concentrate here in this section the cut related thread. So, first let us try to understand the mechanisms of cut protection. So, here the cut mechanisms are of different types. First is the polymer cut resistant mechanism. So, any material, any textile material is made of polymer, okay, and first the polymer will get damaged, okay, then only the structure will be damaged. So, first let us try to understand the cut of polymer. So, mechanism of cut resistance of polymer. Now, this is a say fiber or polymer. When a blade cuts a polymer, the total energy has two parts. So, the energy required to cut, it can be of, it is of two types, two parts, one being the energy to cut the molecular chain. So, polymer is made of molecules. So, molecular chain has to be cut. So, that energy is required, and other is the energy contributes to viscoelastic and plastic deformation of the material. So, this energy, so this is a polymer, it is made of different, it is made of molecules. So, the molecule will get cut, for that we need one part, and another part is that there will be viscoelastic or plastic deformation. Before cut, the material gets deformed due to the force applied by the knife or any sharp object. So, that requires some energy, that will absorb some energy, and then other rest of the energy will be used to cut the molecules. That means, when the molecule is cut, that means the polymer is separated into pieces. So, total energy is energy to actually cut the molecules, that is chain breakage is there. For chain breakage we need the energy and deformation energy. There will be maybe sliding between the molecules, there will be deformation, typically it will be extended, and viscoelastic or plastic indentation or stretching under the blade. So, as I have mentioned, so when there is a force acting, force by the knife, force acting, sharp object force acting, the material get deformed, there will be molecular sliding, the stretching of the material. So, in a polymer, so the total energy is actually divided into two parts. If we see here, energy components in polymer cutting, one is chain breaking, energy to sever the molecular bonds, that is important, and the deformation energy, the energy for the material distortion. So, if you combine it, so this is the combined cutting energy. So, when we try to cut a material, a polymer or fiber, first one part will go to the chain breaking, another two part of the energy will go for the deformation. This is the polymer cut resistance. Next is the fabric cut resistance property. So, fabric cut resistance means it includes the yarn or fiber, individual fiber. So, individual fiber we have already discussed the deformation. So, fabric cut resistance mechanisms are of different stages. The stages starts from this part. First stage, let us see. Now, here when the fabric initially hit by the blade. So, there is a fabric and the blade say hits the, this is the blade which hits the fabric. What happens there? There the fabric initially in contact with the blade, first stage, that means it will start applying the force. First it is in contact with the fabric, next stage will be the fiber portion below the knife. So, fiber portions underneath are pushed and extruded from the other side of the blade, at high angle causing greater compression. That means, when it is so that fiber section extruded and they are pushed then next is that as the blade cuts deeper, the fiber's effective cross sectional area decreases. So, that means this is the fiber, and when this blade cuts, it enters. So, fibers cross section, effective cross section will be lower. So, fiber cross sectional area reduced. So, effective area of the fiber decreases because it is cutting, and that is why the stress concentration will increase. So, stress will get concentrated because the area, effective area of fiber is decreasing. And here that is why tension increases, the tension within the fiber rises. Tension builds and then split the fiber in the remaining area because of the stress concentration here. And final is that pushing the cutting blade against the fiber is the pure compression and compression shear under the normal load. That means, the cutting we can cut without any movement. So, blade pushed against the fiber. So, like we can even we can cut anything, any object by a knife, heavy knife, by simply by pressure. As the cut edge area is very small, so pressure will be important, that will actually separate the object, that is the material, and that is also cut. That cut is basically by compression, but also we can move the blade, and that is compression along with the shear under certain load, normal load. So, if we try to shear without any load, then there will not be any cutting. So, either by compression or by compression shear under certain load, or maybe combination. In most of the cases, these are the in combination it takes place. Cutting by pressure is basically it is intentional. If we want to cut by pressure, it is intentional, but normal cases in industry, the cut related injury takes place, or at home, like cut, compression and compression with shear under normal load. This combination is a major incidence of the cut, but here we should remember the certain load is always there. Without any normal load, cutting will not be there. Okay. So, that is why the fabric should be in touch with the blade under certain load. Now, we see here, this is the for any other material, not only for textile material, for any material, this is the schematic diagram for the force resulting from the applied normal load of the vessel. Here what we have discussed earlier, it is a combination of compression and compression shear, and this diagram is only for compression normal load. So, how the loads are getting distributed, forces are getting distributed from applied normal load of the blade. So, Fn is the load applied by the blade, normal load, and mu is the blade to metal friction, blade to metal, this at this point, this is the when it is entering, penetrating inside, there will be friction between blade and material due to vertical movement. So, there is a vertical movement is there. So, higher the friction, lower will be the penetration, because the energy will be absorbed by the friction of the material. So, F load is the resultant force of the pressure on material, which is caused by the applied normal load Fn. Okay. So, these are the load distribution, and alpha is the half of the apex angle of the blade. So, this is the apex angle, and this type of load distributions are there for any type of compressive cut. But in case of, as I have mentioned here, this is for very simplified diagram, simplified force distribution. But in case of textile material, fabric, these are not that simple, because in fabric the situation is more complex, as there are more constraints, because of that is such as interlocking between warp and wave threads. So, in addition, this is not a straightforward material, so there will be interlacement. So, they get interlocked. So, interlacement between warp and wave threads or loops in the knit structure and the entanglement of fiber in nonwoven. So, these are the additional constraint coming into picture for textile materials, and their movement will be, they are not actually, when there is any cut related pressure or any shear, the fibers, yarns and total structure will also have some motion, relative motion. So, that will change the mechanism. So, in case of textile material, this mechanism is not that simple. In addition to that, the different frictions have different contribution to the cut resistance. So, we can change the friction of the material. So, the friction between blade tip and the material reduces the cut resistance. So, in textile material is one issue, and the friction between material and the blade is actually also important. Now, try to see if the friction between blade tip and the material. So, this is one friction will be there, another friction will be at the blade surface and the material. There are two types of frictions here. So, in case of friction between blade tip and material, if it is higher, that will reduce the cut resistance. So, that is important. If there is a higher friction between blade tip and the material, then it will reduce the cut resistance. That means, the material will penetrate easily, that the knife will penetrate easily because of the higher friction. Okay. And if the sliding, suppose the tip mu t tip and mu side. So, mu t is the tip between the blade tip and the material. So, if mu t is higher, what will happen? The material will cut easily due to the sharp object. So, that will reduce the cut resistance. But on the other hand, if mu s is high, that will restrict the penetration. So, the side of the blade and the material, it contributes from the gripping force and increases the cut resistance. So, if it is high at this, then cut resistance will be improved. So, if the material will be, the cut resistance will be improved. So, that we have to design our even the knife for this type of processes, but like cutting process which we use, we can design the material like we can have certain differential friction. Okay. So, different friction we can generate here. So, here if it is high, tip friction is high, it will penetrate easily, and at the side if it is high, this will restrict the penetration. Now, we can see here at the tip, with the tip the friction that we have discussed, and with the side, this is with the side. So, the cut protection mechanism includes different stages. So, the repeating sequences are there. What are the sequences here? You can see first, densification of material. For any material, when we apply normal force by knife or any sharp object, the material get densified. So, the in case of textile material also, suppose this is a non-woven structure, when there is sharp object is there, this fabric will first get densified, density will increase, compact. Okay. This is the densification will be there. Next, there will be compression, and this densification will come together. That means compression, here we are talking about the compression of the material which we need to cut. First is densification, is the densification of the structure of the fabric like non-woven. Then the compressive force will come onto the fiber, and then due to compression there will be cut in the material. And after cutting, after the knife cuts or sharp object, then it will get relaxed, because no other forces are there, and this total material, any material after cutting, suppose this after this is cutting, then they will get relaxed, because there is no normal force again, they will be separated into two parts, they will get relaxed. So, these are the sequences. In this is the including this in the cutting of textile substrate. So, this is happening in any cut protective textiles. If it cuts, once a path is cut, the stored elastic energy. So, when we are pressing that, there will be elastic energy will be stored, and when the once it is cut by compacting, then the compact stacks is released, that I have already discussed, and slits open, that is called relaxation will be there. In case of any yarn cut of yarn, if we see there is a yarn, very compact yarn or textile material, this is a compact yarn is there. Now, if it is cut, we will see but at the edge there will be relaxation. So, you see other portion may be intact, but at the edge there will be relaxation. This is the relaxation we are talking about. So, the goal of the design of cut protective material is to delay this moment. So, here this process, if we try to delay the densification, compression and the cutting process, if we delay, then we can save ourselves, that is why it is protected. It is not that the cut protective textile cannot be cut, but if we can delay it, then the sharp object can be removed. That is the basically goal of the cut protective material. So, making the blades spend some more energy, more time as much as possible in indentation and sliding before it happens. So, that is because cut protective textiles main idea is to delay the process of the mechanism to cutting, and it absorbs some energy. So, we cannot say that the cut protective textile it cannot be cut, but after certain time if we keep on pressing or maybe shearing, there will be cut, but if it delays, then the person will be protected. There are different types of materials for cut protection, and which are mainly used for cut protective textile, which are mainly used for cut protective textiles manufacturing. So, majority of cut protective equipments is fundamentally textile product, that we should know. So, cut protective materials are mainly for from the textile products, and they are made from fibers, that may be metallic fibers also. When talking about the difference among the cut resistance, one has to bear in mind that different materials have different ranking by different testing methods. This is very important. We will discuss later. Different testing methods have different process of cutting, and a material which shows higher cut resistance, but for a particular type of cut, but may fail in other type of cut. So, that the process of cutting will also are responsible for the different types of cut resistance property. So, cut resistant fabrics are engineered with high modulus fiber, tough fiber. It should absorb more energy. So, one is high modulus, it should absorb more energy and hard fibers. Okay. From this type of fibers we produce the cut protective material like para-aramid. It is very high modulus. So, ultra high molecular weight polyethylene or stainless steel and their blends. So, we use generally for this type of cut protective textiles. Now, if you see the properties, so specific stress of different types of materials, here aramid fibers are there with very high specific stress, and if you see high performance polyethylene like ultra high molecular weight polyethylene. So, they have very good specific stress. So, basically specific stress basically the stress breaking stress per unit mass, and here you can see the specific modulus. So, carbon fiber has got very high modulus, PBO has got very high modulus and specific stress. So, these fibers are particularly HPPE, high performance polyethylene, they are lighter. So, that is why specific stress is very high. So, we can select these are the fibers which are fundamentally used, mainly used for cut protective textile material. Then we have different types of materials used like aramid, actually the one of the fiber is Kevlar, which is developed by DuPont. So, we will discuss all these fibers subsequently in the like aramid, ultra high molecular weight polyethylene. So, these fibers, what are their characteristics, why are they being used for cut protection, we will discuss in the next module, next session. Till then, thank you.